All right, excellent. Welcome, everyone. So we had a little bit of a scramble for who was going to host today's webinar. I'm actually sitting outside in a public space, and you may actually hear background music. Or if you see me kind of dancing along with the music, that's what's going on. But glad to hear that the sound is good, and glad that we could bring the webinar to you as scheduled. So let's go ahead and get into it. We're going to be talking about agentic document extraction today and really focusing on the kind of autonomy, the agentic portion, and also the auditability. I've got probably like 10 to 15 minutes worth of slides, and then we're going to be doing a lot of hands-on and product demonstrations. So I do want to review kind of what problem are we solving here? So why does document automation break at scale? Give you a quick introduction to the company, quick introduction to the product, share some of our benchmarks that we're very proud of to establish accuracy. And then we'll go into security and deployment options, which are always big topics for enterprise use. Review some common use cases, some case studies, and then get into those demos. I'm a pretty fast talker, so stick with me. Hopefully you will not be bored, and you can always go back to the recording. If you missed something, do use the Q&A section of Zoom if you have questions. I will pause along the way. So what is hard about this problem? So we talked to some people who have been working in the OCR trenches for, 8 to 15 years. We talked to some people who are new to the space. If you are new to the space, you will quickly find out that you're going to struggle with image quality. So we run into scans and photographs and wrinkled pieces of paper. You're going to run into complex layouts or sometimes even documents that are rotated. You're going to run into handwriting. You're going to run into mixtures of languages. And you're going to run into like every sort of figure and chart under the sun. And so while it is possible to stitch together multiple tools to make this entire pipeline work, you've created a fairly brittle system in doing that. So this is really the problem we're trying to solve. Like, can we create one model that can really just understand all of this complexity, be reliable for you at scale, and be kind of a replacement of this kind of like spaghetti of stitching tools together. So as far as LandingAI is concerned, we've been in business, I guess, since 2017. So we are not one of the brand new .ai companies. We're coming from the computer vision space, and we have another product in the deep learning computer vision space. We were founded by Dr. Andrew Ng, who's well known in the data science, machine learning, AI community as founder of Coursera. He's also done major stints at Google Brain, serves as our executive chairman and scientific advisor in images and documents. Some of the things we're really focusing on here on the right-hand side, you're going to hear me repeating these terms over and over again so that they kind of stick with you. So reliability at scale, making sure things are audible and traceable. Trying to make this as autonomous as possible using an agentic approach so that you don't have to train or fine-tune on your documents. And providing APIs to developers, which is going to allow them to scale up these processes. So today we're going to be talking about agentic document extraction. There's actually a lot of great details on this slide, so forgive me for kind of reading them to you. But we're providing a set of modular APIs that can take those complex real-world documents and turn them into accurate structured outputs. That process is going to be fully audible and traceable and production ready. On your side, it is zero shot. You can drop in any document type. So, PDFs, PowerPoint files, Excel files, JPEGs, PNGs. There's, a list of about 30 supported file types, and there's no training or fine tuning required on your part. What you're going to get back are visually grounded, verifiable outputs, and we'll see those in detail in the demo section. And you'll get very clean JSON, which is ready for your production pipelines. Once you've kind of played with our service in our visual playground, we offer 3 different ways to interact with us programmatically. We have a set of REST APIs, and then we have a Python library and a TypeScript library, which wrap around those APIs. So that's agentic document extraction in terms of its capabilities, but what exactly are the APIs? So currently we offer three APIs for three different parts of that document processing pipeline. So there's going to be parse, split, and extract, and typically users are going to use them in this order. You always have to parse first. So the parsing step is actually just going to make a machine readable Markdown and JSON version of your entire document. So think about this as kind of like the digital version of the original. Split is able to take that longer document and break it down into subdocuments. So this is often helpful if things have been previously concatenated or if you want to split based on a particular field in those documents. And then extract is where you're going to pull out specific key value pairs. You define your extraction schema, so you can pull out simple things like names and totals, but you can also pull out unstructured information from those documents. And I'm such a visual learner. I think I didn't really understand the power of extract until I saw it. So I've got quite a few demonstrations for you a bit later. So three APIs for you to use. Note that Parse comes in a sync and an async version. So sync is good for shorter documents. Async is going to be great for, a 300 pager and you don't mind waiting an hour to get the response back. So again, some of the kind of key design features here, we've focused a lot on this accuracy, auditability, autonomous. I am going to show you the benchmark as kind of evidence around the accuracy, but we've really is paramount. So financial services, healthcare, legal, and I feel like I'm missing one other, a lot of transportation and logistics. And these are really industries where, like in FS and in healthcare, everybody's looking for that 100% accuracy. What we've been able to provide is a confidence score that goes along with the extraction. So for industries that are, able to accept maybe 99, 98% accuracy, which is native out of our system, you can just pass that into your pipeline. If you need that 100% accuracy, it allows you to use the confidence scores to create some sort of human in the loop review system to review any low confidence regions, have a human actually correct that, and then the pipeline continues for there. Of course, we're continuing to iterate and improve the accuracy so that this kind of human in the loop becomes a lower and lower burden over time, but it certainly is available. And, important to know that, when we do the demonstration, you're going to see me do one document at a time, but we are designed for scale, so we can absolutely handle thousands of pages per minute in parallel from you as a customer, as well as all of our other customers, right? We have to reserve bandwidth for everybody, but if we can do 1,000 pages for customer 1 and 2 and 3 all simultaneously, you get a sense for how large our pipe is to actually be able to process these. All right, so a little bit on the benchmark. Actually, because I'm traveling, I only have one screen, so it's going to be a little bit awkward for me to kind of like leave the slides and go back to the website and so on and so forth. So I think I'm going to finish with the slides, and then I'll actually show you this benchmark in more detail. But these are our results on the Doc VQA dataset. VQA here stands for Visual Question and Answering. So this is a data set compiled by some faculty at UCSF and UCSD, I believe. And they've tested many state-of-the-art models against this benchmark. You can see that LandingAI is currently sitting at the top of that leaderboard. We're actually coming in above human performance. People often ask, how is that possible? And that's because these documents are actually really difficult and you have to hunt for the correct answer in the document, and the humans don't always get it correct either. How is this accuracy possible? So we have a proprietary model that you can only get from LandingAI. We call this our DPT family of models, stands for Document Pre-trained Transformer. We get a lot of questions about are you just wrapping open source LLMs? No, you are getting something proprietary that we have created. And it really has these main capabilities as well as a few others. So we've trained this transformer to really be able to detect the layout of your document before anything else happens. So what is the reading order? What are the components? And this enhanced layout detection then allows us to apply a very intelligent chunk ontology on top of that. So saying, this is a logo, this is a text block, this is a signature. And then for each one of these chunks, they actually then are routed to different agents for different downstream processes before all of that comes back together for you. And just two of them are shown over here on the right-hand side. So something that's detected as a figure goes down the figure captioning pathway, and something that's detected as a table goes down the agentic table captioning pathway. So this entire DPT transformer is doing all of this for you behind the scenes, right? So it's almost like you give us the page, we rip the page apart and send it through different components and then assemble the response back and present it back to you as clean JSON. As far as how to interact with us, you really have two options. So today we're going to be working in the cloud version, and this is a multi-tenant SaaS environment. It is extremely fast. It's extremely easy to create an account and be up and running within minutes. The cloud version has all of these compliance certifications that you see over on the right-hand side. So SOC 2 Type 2 compliant, HIPAA and BAA. We can offer zero data retention. We've got 99% uptime with redundancy. So all of these apply over here to the ADE cloud. If you do need additional enhanced security for enterprises, we offer VPC deployments inside of AWS, Azure, or GCP. This is going to have a significantly higher total cost of ownership than the cloud. So we always encourage you to rule out the cloud before we get in depth talking about VPC, but it is absolutely available. And a lot of the financial services and healthcare organizations that I mentioned previously do require this. Okay, couple kind of results from early adopters, right? Like this whole space is still fairly new. We've got a couple enterprises that went with us early on and are already starting to see some amazing business results. I'm not going to read you this entire slide, but you do get a sense for, we're working with a major bank, a major pharmaceutical company, a major energy engineering company, underwriters, right? And they're recognizing business results from this solution, not just kind of at the data science, like, improved accuracy. This is one case study that I do like to double click on. Dr. Declan Kelly has been really generous with his time participating in some of our webinars, blog posts, videos. So there's actually a great video of him actually showing the end solution that they have built on top of ADE. Now, the solution provided by Olus Medical is actually used at over 400 healthcare centers. I think he mentions, Stanford and some other leading medical centers that use the Olus platform. And underneath the Olus platform, Agentic Document Extraction is fueling some of those responses that are being returned to clinicians at the point of care. So would definitely encourage you to learn more about this case study, especially if you're in the healthcare space and especially if your use case is RAG. So I'm very proud of this, to be able to provide kind of a premium accuracy solution that's actually making a difference at the point of care. And I think with that, we'll probably just range my windows here and we'll go take a look at it. So I always like to start by showing you how you can actually create an account. So I'd love for you to maybe create an account after the webinar so you can watch some of the examples we're going to go through. But if you come to our homepage at landing.ai, you can click this button, Start for Free. It's going to allow you to create a cloud account either in the US or the EU region. So choose which region is closest to you, create your account. You can use a corporate email, you can use a personal email. We can always switch those for you at a later date. But you'll basically be inside our playground experience within a few minutes. And here I have my tab for benchmarks. So I'm going to segue into benchmarks, and then we're actually going to go into the playground. From our website, you can access this benchmark study. It's actually flashing up here in the header. And definitely do read the blog post. Like we tried to keep the too long didn't read pretty short so you could actually read it. But we've also exposed all of the successes and failures in kind of an interactive experience. So within the blog post, if you click on that link, you'll be taken to this gallery page. And in the gallery page, you can actually view some of the documents that are part of this VQA benchmark. And this will also help you understand, why humans sometimes get these answers wrong. So let's see, what would be a good one? Let's try this one. How many days were the subject JW on the baseline diet? Okay. So that is the question to be answered. So you can see this original is somewhat degraded. It looks like a scan or a photograph of the original. There's a table here that does not have clear horizontal lines nor clear vertical lines. That, is a challenging problem for OCR. Here's the subject JW, and we need to respond with how many days was he on the baseline diet. I, as a human, think the right answer here is 40, right? And so this is a sense for the type of problems that are in this VQA benchmark. I have to figure out how to actually get out of this one page. There's the close button. So indeed, the ground truth answer was 40, and our answer here also was 40. I have no idea what just happened. Okay, so good enough on the benchmark. So you can explore all of the successes and failures in the gallery, and it's actually a great way just to see the variety of documents that the system can handle out of the box. So, Adrian, let me take a sip of water and see if we have any questions, and otherwise we're going to get into heavy demos.
Let's see around questions. Yes, we do have one here. And do I need to orient the page first before sending it to landing?
No, you don't. Actually, part of the JSON response, you will get an angle of rotation back. So we will automatically detect the rotation. If it's completely horizontal, right, you'll get back a 90. But if it's like a photograph and it's like 3 degrees off, like you'll actually get back like it was rotated 3 degrees. You do not need to supply that information. You don't need to open the document and know the angle of rotation. But we do need to detect that as part of that pipeline in order to make everything rotated pages. So we're aware of that issue. So this is the visual playground. I do like to emphasize that we are fundamentally an API-based service. So over here on the left-hand side, you can generate your API key, access the documentation for the REST API and for the libraries. But I think you'll quickly see why we've created this visual playground. Makes it really easy to get started and test some of your own documents. So for these mixed audiences, I quite often do a demonstration using utility bills. This is actually the same demonstration that we have up on GitHub. So you can actually access these same 9 documents and you can actually see the results from each one. So let's take a look at what's in this input folder. So these are the types of variety that you might get with utility bills, right? So every utility provider across the country has a different layout and structure. And you also see a mixture of kind of digital native PDFs as well as photographs, including some rotation and some crinkling. So we can take any one of these documents. We'll actually work with one of the more challenging ones. So we'll take electric C, and we'll go ahead and upload that file. Oh my gosh, I didn't realize all my screens were going to show here. Let me see if I can just drag and drop it. This is the hard part about having only one screen. There we go. So what's happening right now? So like we said before, Parse always comes first. Parse is calling that document pre-trained transformer. And as part of that process, it's understanding the layout, it's assigning a chunk type, and then it's routing those different chunks in different directions to return a response. So what you see overlaid now are the various chunks. So we have a margin chunk, we have a logo chunk, a text chunk, another text chunk, and so on and so forth. In this one, we also see one kind of scan code. So anything that's got a barcode or a QR code will come back as a scan code chunk. And our median processing time is about 8 seconds per page. It depends on the complexity of the page, of course. Um, so this is the zero shot parsing, right? And it's going to allow you to zoom in on particular values, right? So I can zoom in on the original. I can take a look at the parsing result. And this is why people really like the visual playground, is to be able to verify, kind of quickly verify information kind of going back and forth in this way. So here is the Markdown output, and you can download the Markdown on its own. And then there is also the JSON output. So notice in the JSON, the first line up here is Markdown. This is actually one big, long horizontal response that contains everything that's on this page. So the Markdown itself is a top-level object in the JSON. The next top level object then are the individual chunks. And notice that we had said chunk number one was marginalia. So that's what we're seeing here is marginalia. It's the first chunk. It appears on page 0 with these top left, right, bottom coordinates. And it has a unique identifier that ends in C98. So everything on the page has visual grounding associated with it. And using these coordinates, you can create those human in the loop systems where you're actually surfacing individual chunks. So say that I'm looking for a number like, now I'm actually feeling bad that I used somebody's shut off notice for this example, but let's try to query for this $177 and $11. So it says like this month's charges and credits. So say that we wanted to extract and we wanted to ask for, current month charges. And we're going to do a lot more extracting later, but this is really just to understand the visual grounding. Filling in the description, you should always fill in the description. I'm skipping it just in the interest of time. So we'll collapse the sidebar here to have a little bit more space. All right. So I've asked for current month charges as a number, and I am getting back 177.11. That's great. So this is my extraction response, and then this is my extraction metadata. And in the metadata, I'm getting this chunk reference, which ends in 0E8. And we should be able to match that back to the parsing response for this chunk. So it looks like this is chunk number 13. And just to show how all of these pieces connect, I should actually be able to click on chunk 13. It'll scroll down to that region. And again, I'm outside on a public Wi-Fi, so we'll give this just a moment to catch up. I probably should have caught up by now. Let's all right. I'm gonna be a little forgiving here. All right, let's try that again. Let's get no. Okay. Where is okay. Oh my gosh, that took a little bit. Okay, so here we are on the chunk that ends in 0E8. And this should be chunk number 13. And within this chunk, I should be able to find where that value came from. So indeed, the 177.11 was embedded in this chunk. So connecting back to the slides when we talk about visual grounding, for any value pair that you extract out of this document, you will know exactly which chunk it came from, and you'll know which page and which location that chunk occurs by connecting these unique identifiers. Okay, so with that as introduction, I usually only parse one document live, and then I show quite a few other examples just for variety's sake. So I've got a bunch of other tabs open here. So here's some other energy bills. You saw this one also in the input folder. And oh yeah, okay. So I always forget which examples I've selected in advance. So here's a 4-pager, right? So if you do have a longer document, you can tab through it. This one also has a figure, which the previous one did not have. So we will make our best attempt at actually extracting the information from the figures. So on that slide where I showed where we're kind of tearing apart the document and then we're sending for figure captioning and table captioning, if the X and Y axes are fairly clear, so this is a combined line chart and bar chart, and you can see that we're making an attempt to actually pull out the values. I'm actually super impressed with this middle column with the estimated reading. If you look carefully at the original, when your meter is read, some of them, like the person actually comes to read your meter, and then some of them are estimates. So August and December look like they were actual readings, and then the others were estimates. So that is pretty cool. Okay. So next couple of tabs here, I think, are finance examples. So this is a 48-page 10Q from NVIDIA. We talked to a lot of financial analysts that are trying to extract information about company financials, right? So company financials are going to have lots of these tables. They're all formatted a little bit differently. And this would also potentially be a good use case for split. This is a place where you could ask, which of the pages in this 48-page document have the income statement? Which of them have the balance sheet? And you can actually pull those pages out of the larger document. So it looks like I have done splitting on this one before. And let's go ahead and actually just do start over. And if I start from scratch, okay. So this is the hard part about reusing documents. So it's kind of going to remember what I did. But basically, I would create a new split type and I would say, which pages are the income statement, new split type, which pages are the balance sheet. So I can kind of save you watching me type these, but so say I want which pages are the income statement. If it's not clear, you always fill in the description. I tend to skip it in demos. And then we can split this 48-page document and it will come back to me with an identification of these are the pages that contain an income statement and these are all of the other pages. So you can have multiple different split types here. So you can ask for, what are the balance sheet pages? What are the cash flow pages? What are the kind of footnote pages? And often you can then route that document into different directions based on those different split types. So it looks like we've got some income statements here on page 3 and 4, another income statement on page 11. This looks like it's the notes that go along with the income statement. So this is kind of the idea of how you use split. If you're not getting good results, it's typically because you skipped the description. Here's another example from finance. We talk with a lot of teams that are analyzing these types of investor presentations. So here we're seeing kind of our first PowerPoint or Google slide type document and kind of what the parsing might look like for that. So here we're identifying quite a few different figures. And again, for a figure such as this one, you'll get, as best as possible, a representation of that figure. This might be a more interesting one to click on, right? So it's telling you that there's a pie chart here and trying to identify all of the different sectors. But this is the type of document that's actually just really difficult to feed into a RAG pipeline because each page is just so different, right? These types of presentations are designed for people. They're not necessarily designed for machines. But this is a great way to, again, kind of zero shot, just kind of get extraction of all of the content of a presentation like this. Sticking with finance, in the KYC process, you would need to kind of authenticate the owners of a company. This also shows off our attestation file types. So here we're detecting a stamp from the Secretary of State, places where there are signatures. And as much as possible, we will try to read the signature. So here they're both saying signature illegible. But for people who have very nice handwriting, you'll actually see not just the printed name, but also the signature extracted. And here's an example of the extraction on the stamp. So important in KYC, we see a lot of like stamps on logistics and transportation documents. We see a lot of like signatures on doctor's orders. So kind of a unique ability to detect those signatures. And then I pulled out this example. This is more from insurance, kind of as a part of, FS&I. So this is what's called a loss run report. We're going to take a deeper look at this when we get over into extract. But the reason I like to include this one is that this first table is actually a really nice kind of clean table. It's got clear rows. It's just got one set of headers. But if you look carefully at this table, like this table is a nightmare even for humans. So I'm going to zoom in on this a little bit. So if you look at the correct way to read this table, like the policy number is this first row in down here, right? And then the claim reference is this thing that's on the second row. And the claim occurrence is this thing that's on the third row. I mean, this is actually a terrible way to design your table. So there's like 4 headers here, which have to be associated spatially with these 4 different lines, right? There's 2 headers here, which need to be associated spatially with these lines. So this is actually a disaster looking table to me. And you do get, an extraction of everything that's in the original, right? Like now we have all of the words that's in the original, but you still don't visibly see the structure. So trust me that like when we get over to extract, that we're actually going to be able to take this output and understand it correctly with those spatial relationships, even though it kind of came from this ugly original. So that's why I like to include this one. So stay tuned for that. I think next we have a couple healthcare examples. So in healthcare, there's a lot of handwritten like intake forms. So, it obviously always depends on the person's handwriting, but it seems to understand my handwriting okay. This is also a nice way to illustrate what you get back with checkboxes. So here, I have 7 yes/no questions where the instruction is to circle them. So we're getting kind of a markdown representation of all those circles. And then here's another way to represent, circle all that apply. So you have all of the different options listed. And if you look carefully, only the 4 that are circled actually have the checkbox behind them. So it's an example of a user submitted document with some handwriting and some of this circling going on. Here would be another example from some of the healthcare companies we talked to. This would be more like the type of document that Olus Medical is ingesting. So these are nice, clean, original research papers. Couple things to note here is that, research papers are often presented in 2 and 3 column formats. And so you want to make sure you're understanding the column structure correctly. So, here we have, chunk number 27 at the bottom and then going up to chunk number 28. So just it seems simple, but a lot of OCR systems kind of lose track of the reading order that 27 flows into 28. I also like this one because it has several of these tables that have no clear horizontal or vertical lines. and where the spacing is off. So this is actually a very difficult table to interpret because the rows have unequal spacing, and there are no lines for the rows, but you can see kind of the quality of the extraction over here. This one I think also has some nice figures in it. So this is not a figure that is clearly a bar chart or a pie chart or, anything standard, right? So it's a very non-standard figure, but you get a very nice extraction explaining what's going on in this figure. So it's detected as a flow chart. It understands that there are 4 steps being shown. For each of the steps, it's describing what is the arrow coming from and what is the arrow pointing to. And so you're getting kind of a description of this figure. Again, that's all zero shot. A couple other from healthcare. Somebody asked previously about rotated pages. So here's a document that has within it some rotated pages. And the pages I usually draw attention to, again, are some of these tables at the end. So this page is rotated and it has multiple merged cells. So you can see here like the cycle 1, cycle 2, and we're able to reproduce those merged cells in the markdown. And this is actually, oops, hit something on my trackpad. This is also a very, very difficult problem. So we've put a lot of effort into reproducing tables with merged cells and getting those mergers correct. Another nice example in here, another very non-standard figure type. So, if you look carefully here, this is the dosing schedule for a set of medications. And, here, if you look at, taxane is supposed to be administered on days 1, 8, and 5 in cycle 1. Those are these 3 red arrows, and 1, 8, and 15 in cycle 2. So it's able to take something extremely non-standard and actually like represent the meaning of that in terms of kind of what is the dosing schedule of these 2 drugs as part of this clinical protocol. A couple more examples. Okay, so that was the end of the healthcare examples. So these are just 2 questions I get a lot about support for multiple languages and support for Excel files. So I've found that one of the best ways to show language support is just to find a document that has lots of different languages side by side. So I'll leave this up for a moment. This may be a good place to take questions. If you read or speak any of these languages, you can also kind of check the extraction accuracy. But we do have native support for over 15 languages that we call kind of high support, and another probably about 20 that we call moderate support. Most of the ones in the moderate category, if it's a digital native, it's going to extract quite well. If you get into handwritten in those moderate categories, like that's where you're going to start to experience some problems. But let me pause there. I've been talking a lot.
So we have a great question. Thank you for the kudos to LandingAI as a superb platform. The question is for an organization deploying LandingAI at scale, what potential risks should a company evaluate, particularly around data security, model performance, and vendor dependency?
Okay, there's a lot to unpack there. So I am going to touch on security. On model performance, you should have your own golden test set to actually evaluate accuracy, much like that DocVQA benchmark. So absolutely evaluate accuracy on your own documents. Vendor lock-in is, I don't know what I want to say about that on a public webinar. I think, there's a lot of places where you're going to make a buy versus build decision in your business. You just can't build everything. Like you're going to have to buy best of breed components. And like we're pretty certain ours is the best at the moment, and our goal is to stay at the forefront. This is really not something you want to build. So I think this is more an issue of like which vendor to go with rather than, worrying about should we build this ourselves to avoid vendor lock-in? So everyone has a personal opinion about that question. But let me show the last parsing example, and then I'll actually jump over to security to connect to that question, and then we'll go back to extract. So this is the last parse example. This was originally an Excel book, Excel SX from the Department of Education. And so it has multiple tabs in the original. And what you'll get back in the visual playground here is an extraction of the data that's in each one of those tabs. And then I can click on this one and it'll scroll to the relevant section in the Markdown. More useful here might be to look at the JSON. So in the JSON, you will see, okay, the first tab was called list of tables, which you see down here. And the cell range was A1 to B9 is where the actual data occurred. So you will get back kind of the HTML of the table. And then you'll get a reference to like which tab it came from and what cell range it came from. So if you do need to parse Excel files, the result is a little bit different, but try it for yourself and kind of explore the structure here. Okay, yeah, on time check, I need to speed up a little bit to show you my cool extract examples, but let's talk about security. So the page that I'm showing you here is actually available in the footer. So it is this page right here, security and compliance. And it's going to go through all of the compliance frameworks. So definitely show this to your IT team. These are typically the types of things that like an enterprise security assessment is asking us about. And we do have the ability to respond to more detailed security questions beyond what's publicly available. For people that are kind of smaller businesses or individual users, typically this is sufficient. I do like to draw attention to the zero data retention option. When you first create an account, it will not have zero data retention by default. This is something available at our kind of minimum subscription level. And when this option is enabled, the data is processed in memory and is not stored by us or our sub-processors. It's used exclusively for the extraction process and immediately discarded. So this zero data retention is required to be HIPAA compliant in the US. So if you're processing healthcare information, you'll need this. Most of our financial services customers also opt for zero data retention. So just know that it's not on by default, but it is an option. And then we also have the Trust Center. So this is also available from the links in the footer. This is where you can actually request some of our reports, like the SOC 2 report, right? So if you click here, it's going to give you this form where you can request access. This is going to be sent to our legal department. So if you are kind of needing to do an enterprise security evaluation, direct those people first to the Trust Center, and then they can absolutely request all of this documentation. And then if there's custom documentation, we can kind of do that over email. At that point, we would assign you an account executive to actually handle that back and forth paperwork with you. While we're here, I'll skip over to pricing real quickly. So we were just talking about zero data retention, and I mentioned that zero data retention does require a subscription. So we have pay as you go. When you first create an account, you're going to have 1,000 free credits. That's going to be enough to process about 250 pages. So it's pretty generous to really kind of test for free. After that, you can reload your account. I think the minimum is like $10 reload, so you can just pay as you go. If you do need zero data retention, you'll need to come in at kind of the minimum subscription, which is $250 a month. This is also month to month, so it's going to give you better unit economics on the credits. And then as you go up in volume, these plans max out at about $5,000 a month. If you're spending more than that with us, we definitely want to meet you. We definitely want to devise a custom plan for you. And we definitely see people kind of growing through these stages. Sometimes they go from left to right, across 4 months, and sometimes they go from left to right in 4 weeks. It all depends on your document volume and how quickly you're testing. Okay, we need to do some extraction and we need to do some sample projects. So I'm going to talk briefly about the documentation. So the documentation is really, really wonderful. I refer to our own documentation all the time. So this is available at docs.landingAI. The documentation is public. You don't need an account to review the documentation. Here you'll get information about how to use the REST API, how to use the Python library, and how to use the TypeScript library. There's also some really helpful quick starts available because we want you to be able to quickly convert from using the visual playground to using your API key for the first time. So there's quick starts for curl, Python, and TypeScript, and let us know if you have trouble with any of these. And, some of the things I've mentioned around, what languages do we support, what file types we support, all of this is detailed in the documentation. Okay, let's do a little bit of extraction. So here is an energy bill that we saw briefly earlier, and now we have a much more detailed extraction schema. So this actually comes from uploading a schema that's been prepared in advance. So if you have an established schema that you want to apply, you're basically just going to upload it, and then you can see that structure over here. This is showing 2 levels of nesting. We'll support up to 5 levels of nesting in that schema. This is also a document that we saw earlier, just showing some of the things you can do with those checkbox results. So we had seen these yes/no questions. They're now presented over here as 7 true, false, right? So here's my responses to the screening questions, and they've all been set up as individual Booleans. So I'm getting back false on all of those responses. Another way to deal with these circles would be to do something like this. So I want a list of the pre-existing conditions. And in that case, you're getting back just this list of 4 items that are circled. So this is an important connection between the parsing and the extracting, that in the parse, we just saw kind of this kind of structure, which is certainly more machine readable than the original, but still not something you can put immediately into a pipeline. And so, thinking creatively about like, do I want to represent each one of these as a Boolean? Do I want to just list the ones which are circled? There's a variety of ways you can actually extract against this information. Here's another example. This is kind of as a request for mortgage assistance form. It also has a lot of handwriting and a lot of checkboxes. In this particular schema, we're showing kind of the enum type. So if you want to restrict the response to a particular value, so here, there's a question that says, this property is my primary residence, second home, or investment. And so if only one of those should be checked and you want to restrict those values, you can set it up like this to return just one of those values. So another thing you can do with schemas. This one is included here because in this 2-page facts, most of the useful information is actually here in block number 20. So initially, this doesn't present as something that has a lot of key value pairs in it. But in the schema here, you can see the study details. So details pertaining to the study, and then the report findings. And all of that is actually mashed together in this big text block. But you're able to define a schema to pull out now these structured fields of, what was the study date, what's the number, What's the patient history, which physician did the overread. So I like to include this because all of this information actually came from this large text block. So it's more an example of like interrogating the text block to find the details you want. I like to include this example on schemas because for something like a blood test report, like you wouldn't know in advance what tests are going to be on there. So if you look carefully at this schema, it's saying, okay, what's an array of all the tests that were run? Give me the name of the test, the units, the value. And so there's nothing hard coded here to say like, what's the hemoglobin result? What's the red blood cell result? Because you don't know what tests are going to be on any given document that arrives. So you don't actually want to hard code those things. So setting it up this way, you can basically just say like, what are all of the tests that are run here? And then what are the values and what are the reference values? So again, a nice example of a table that has no clear grid lines. It's also got like this watermark in the background, which sometimes messes things up. And just being able to turn that into nice structured data. Um, so this one we also saw previously just in terms of parsing this document for RAG. But here's kind of a creative use of schemas that people often don't think of. So this is a literature review about the common cold, right? And we've been trying to cure the common cold since like time immemorial. So you can create an array here that says, what are all of the treatments mentioned, their effects, and their evidence. So again, I'm not hard coding anything. I'm just asking for in this article, what are all of the treatments mentioned, right? And you're going to see things like, a vaccine, some interferon, vitamin C, echinacea, zinc lozenges, zinc nasal spray. And so it's able to actually pull out a structured schema of all of the treatments that are mentioned in this review article. And I think I had one last example. Oh, yes, this is my favorite one, right? So I introduced this one earlier. This structure in the original is just like absolutely a mess, in my opinion, right? Let's take a look at the extraction schema. So what have we asked for here? So we want to know for each policy period, how many claims are there? And if there's a claim, what are the claim details? So going back to this example, this document actually covers 5 policy periods. And there's a claim here in 2012, 2013, and there's a claim here in 15 to 16. So this is also an example of developing a schema where sometimes the answer is nothing, right? There were no claims in 3 of those years. So what have we got over here? So we've got policy period. The first period has number of claims 0, and so the claim details is blank. Right. Now we've got our next policy period from 12 to 13. There's 1 claim, and we've got the claim details. And the claim details, again, are having to come from this kind of ugly table, which is actually quite difficult to interpret. And then we've got a couple more years of 0, and then we've got another year with 1 claim and those claim details. So if you're evaluating our solution, I would highly encourage you to use parse and extract together. The teaching point here really is that sometimes you look at the output from parse and you say, like, what am I going to do with this table? This is actually still a mess. But our extract is really designed to work hand in hand with parse to be able to take this, which is kind of still a mess, and be able to turn it into something very structured with high reliability. So if you're testing parse, make sure you're testing extract as well. Let me say a few things about sample projects, and we'll take some final questions. So we've spent all of our time in the UI today. I actually really do like to do some code-based demos, but I'm going to show you where you can get some code examples. So in the documentation, previously we were on this page for guides. There's a tab here for sample code. So as you're ready to start working with us programmatically, come over to sample code. And you're going to get resources. Some sample scripts are embedded in the documentation, and then you're going to get a link to the GitHub repo for sample projects. That's what I have open over here are the sample projects. And there's really two main areas here. There's the use cases and there's the workflows. So most of the content is actually in workflows. So like maybe you want to parse, then classify, then extract, then visualize. Or maybe you want to prepare multiple documents for RAG. Or maybe you want to use the async API for large files. So there are kind of recurring workflows available here. The use cases we're still building out, but there are a few that are fully built out, including the utility bills example that we started with. So in the input folder, you can actually see the same sample documents. And in the results folder, you can see what was the response from parsing that document and the response from applying the extraction schema to that document. So I think, whether you're in the utility space or not, I think just reviewing these complete use cases will give you a better sense for the starting variety that's possible to then map everything to a structured output. And I think ultimately here, kind of we flatten everything into a CSV. So this is an example of taking, those 9 starting documents, which are all very different, and mapping them into nice structured data. So spend some time in the visual playground and then spend some time with the sample projects. Let us know if you can't find what you're looking for. We're always adding to this. So
Okay,
I think I'll call it there and see if we have any final questions.
we do. We have a few minutes here. Let me give you both questions. For the parsing, can I add a field name and description in the API call? And then the other one is how many pages can it process? We have PDFs like 8,000 pages.
Okay. The parsing is entirely zero shot, so you won't be adding any parameters for parsing. So I think the question was about like headers. Is that right? Sorry, I
Correct.
can't actually see the questions. Okay. So with parsing, it is zero shot and there's no parameters that you need to supply. We are actually working on our roadmap on better identification of headers and subheaders based on the formatting of the original document. So if that is currently not meeting your needs, stay tuned because that's coming soon. Second question about large documents. Our official documentation says 6,000 pages as the maximum page size for the PDFs for the async parse. I don't really technically know what the difference would be between a 6,000 and an 8,000. So I can tell you today, if you split your 8,000 in half, it'll work. And I could go back to the engineering team and ask kind of like, why did we put the limit at 6,000? But that's where it stands today.
And our last question, and this came from the pre-registration. What would your thoughts about looking at LandingAI ADE solution versus open source OCR such as Paddle OCR or Layout LMN, etc.? Any thoughts on that?
Uh, I'm going to answer that by doing a little bit of self-promotion. So there's a banner at the top here, and this one here, new course from OCR to Agentic Doc Extract. I'm going to click on that real quickly. This is a free course on deeplearning.ai. And actually in this course, like I teach the module where we compare to Paddle OCR. So maybe it's not in the summary here, course outline. Oh yeah, here, Paddle OCR. So if you want to get my full take on how we compare against Paddle OCR, I would go ahead and watch this lecture. So a little bit of self-promotion there. But of course, we're building up a story that, our agentic approach is superior to what they're providing, but you'll get all the gory details with that.
Awesome. And with that, we'll bring this to a close. Andrea, as always, thank you for a great session. And for our audience, I hope this was a very valuable lesson on how to use ADE within your environment. Thank you for your time. Have a great day.